Welcome everyone to this advanced tutorial of how to use DynamoDB in your game or application in Godot. So this will be a fairly advanced tutorial. You'll need to know about scons and GD native. And here what you're seeing is the end of a platformer tutorial that I did some time ago. If you notice, if I die, I have a leaderboard. So what I'm passing to DynamoDB is a leaderboard, and I'm maintaining the leaderboard through DynamoDB. So if I include here and say I'm another guy, say another, when I set, now my DynamoDB received a new score. And here to prove to you, if I die, here another is here. I'll also get some score. If I do this, I now have 100 score. And this is my DynamoDB table. As you see, previously only there were these three names. If I search, another, which is the one that I just included, is over here. So in this tutorial, we'll need to use more advanced features of Godot in special GD native add-ons. We'll be building one, and we will also see the very basics of what DynamoDB is and how to connect it via RESTful API. So why use DynamoDB in the first place? If you see here, the free tier of AWS, among them, DynamoDB is one of the only ones that actually is always free. It doesn't end up after 12 months, which is also different from other companies depending on the companies you are comparing it to. And of this free tier, you actually have 25 gigabytes of storage in total, and enough to handle about 200 megabytes of requests per month. So this is definitely enough for a small game, maybe even enough for a medium game. Definitely not enough for, say, an MMO, but that's probably beyond the scope of free tier things anyway. So of course, the first thing you'll need to do is to have an AWS account. Here I am logging into my account, and then you need to go to the IAM console, which is where you manage access to the resources you have in your AWS account. You'll need to create a new user. Clicking here in users, add user. You give the username like some name here. I'll just say test. And you need to add programmatic access to be able to generate an access key ID and secret key ID. We'll use this to be able to access DynamoDB. So next, here in attach existing policies, you need to find DynamoDB. And of course, you can just give it full access, but for testing purposes, that's fine. But in case you want to actually ship a game with this, be very wary, because in case someone that you don't know gets access to the IDs of this user, he will have full access to your DynamoDB and access to create new tables and whatnot. So be careful with giving the full access. You don't need any tags, just go to review and create user. Once you create the user, you are able to log into the user using this link, which you actually don't need to do. And here is your access key and secret key ID. Don't worry, I'll just delete this user after the video, so you won't be able to use mine. So with this in hand, we'll just copy to Godot. And also you need to create a new table, a new DynamoDB table. So coming here to services, you can just type DynamoDB. Notice that my region right now is US East 2. This is important. I'll just go back to US East 1. You can choose whichever you like. This is the place, the server region of AWS that your DynamoDB will be instantiated in. So in here, you'll see that I already have a table, but to create a table, just over here, select create table, give your table a name, I'll just say test. And what I will do, you can choose whatever you like. In my case, I will just say the ID of my table will be my game, like the game name. And I'll also add a sort key, which will be my player and player name basically. I'll just leave everything as default. I'll actually delete my old table just because I don't want anything happening with it anymore. So I'm creating the table, just need to wait for a little bit. And now it's created. Just for testing purposes, I'll also add some item inside it. So say I have a platformer game, and my player, which name is, I don't know, John. So I just leave it like this for now. I'll save it. Now I have some information in my table. So let's go back to Godot and see how the script that I created actually works. I'll go through it, but not in a very detailed way. So feel free to stop at any point in the video to try to read the code, or go to the link in the description below to find the code itself for you to use. Just as an example here on our table that we just created, I'll add some more information to each player and session. For example, in here, I'll add a map, which could contain a bunch of things. I will just get the score. I'll create a map with scores. I'll add a number for level 1, and this player had 10, for example, in level 1. And I'll append another number, not here, sorry, over here, append number, level 2, 50. I'll save it. I'll also click here, common actions, duplicate, and I'll create another one called, I don't know, Carl, where he got 100 and 500, something like that. Back to our code. If I rerun everything, you'll notice that now everything is coming here with John and Carl with the scores as maps, which is of like this, of type M. And inside there are numbers of type N with the number over here. So I'll need actually to parse this number because it's right now it's a string, as you can see. And we'll just integrate this in our game. And you can continue using more information over here in your game if you want. Well, in my case, I won't actually track each level, just have one score for each player. So I can just, if I want to change, I can just come here back and say I want to remove this and append just a simple score, which was 10. Something like this, without this little thing. This way I can also change to a number. Notice that I'm able to store different things in different lines if I wish. Well, I will fix this to score, say 50. And now I'll just make sure to read it from my code. And now we can see everything working in my platformer tutorial that I was doing in a series some time back. If you see, my score is 0 right now. If I kill someone and now my score is 100, my last score was 1200. If you see here back in my DynamoDB table, me is 1200. If I go make this back to 0, click save and go back to my Godot game, which is over here. I'll just close it and reopen it. You see, if I die now, first things first, it asks me for my name. Of course, you would like probably some kind of login procedure here. Feel free to implement the one that you prefer. You could also even use DynamoDB for that and hashing the password and etc. So say I'll set my name, and now I just saved my score, which was 0, so actually it didn't save. Let's get a higher score here and die, and now my me is 100 because it's how much score that I did. Back here, if I die and my score is still 0, it's not updated. Going back to my DynamoDB table, you'll see here that me is 100 now. So everything is working properly as we expected in the first place. Right here, I have a very simple scene set up. My code is in this DynamoDB thing. Stop it running. And let's go through my own code that I am including in this tutorial. My code will call DynamoDB using the access key and the secret key that you just created from the IAM console. You'll need also some request parameters, which we'll go through shortly. AMZ target is basically what's the API that you want to call. By default is describe limits, just because it's always available for you to call, so you can test things out with this unenabled. And my code is basically the same code that you would find in AWS documentation for Python. And all information is in this website, which will be also linked below. Here you'll notice that the main thing that I'm doing in my code is creating this authorization header. And with this authorization header, I'm actually able to call DynamoDB directly from Godot. So this is the unique thing about this code. Using this post method, you can see here in Python that the code is already ready to call DynamoDB in a different region than mine. It will generate a bunch of things, which we'll go through shortly, and generate signature and use something called HMAC to sign things with. Godot actually doesn't support HMAC by default. So because of that, I actually also add another library. It's an asset from Godot, which has HMAC implemented in GD native. So many thanks for Summer Play Games, which was able to share their code. Notice that this code is not fully bug-free, so I actually needed to do some changes in his code also to be able to use it in our use case. So first, back in Godot, you'll see exactly the same types of documentation and calls from the AWS documentation of Python. I just converted it into GD script to be able to use it, and created a reasonably easy to use function with an HTTP request to be able to return information to me. First, let's run it and see what happens. So here in my Node2D, I'm just calling the table, which is now test. I'll do a scan operation, which just returns me everything that is within that table up to 1 megabyte. And here I set up the response as a signal, and I was just testing things out here. If I run as it is, you'll see here my player John is extracted from DynamoDB and printed out in Godot. So now I am able to access information from DynamoDB, and changing what's my API call, I can also write information to DynamoDB. Let's go through the details now about the code. First of all, let's go to the HMAC code in which I needed to change. And notice also that I needed to include Godot CPP. So if you don't know how to compile GD native add-ons, I suggest you to take a look on Godot's documentation about that. And you'll find this documentation in Godot tutorials GD native. It will also be in the description below. You'll need a C++ compiler, scons, and a copy of this Godot CPP repository. So this is what I have in my current environment. I have Godot CPP, and scons is also enabled and ready to run. So from the Summer Games Godot HMAC library that I cloned from Summer Games repository, what I needed to do to change things around was in my HMAC CPP, I simply wasn't able to use HMAC as a resource. By default, it was a resource. I changed it to be a node. Probably it's just some mistake in my part, but with being a node, it works well to me. And in the CPP itself, I needed to do some changes. My normal digest, which is now called hex digest, in the very end, there was a unchecked conversion from unsigned int into hex. So I did some changes. I found some helper code in the internet, which I changed somewhat over here. I'll try to find a reference and link it below to thank those guys. And what it basically does is just convert an unsigned int into hexadecimal, considering the two different characters that each one is being converted to. So like this, I have no issues anymore. And I also needed to add another digest method, which instead of returning me a string, which is the one what the original one was doing, it returns me also a full byte array version of it. So it's just equivalent, but instead of converting into a hexadecimal character array, I convert it into a full byte array and return it. So I have these two methods now, digest and hex digest. If I compile it using scons, after compiling also Godot CPP and fixing my s construct to put in the proper place inside my Godot library, as is in my GitHub repository right now, I can just compile this and the library will be updated over there. Back in my Godot, if you guys don't know exactly how to set up GD libs and native scripts, also once again ask you to check this tutorial over here of Godot documentation. The main thing is that I create this node of HMAC. I associate it into a node, which is this one, and now I'm able to call HMAC digest over here and HMAC hex digest over here. Other than that, what I do is almost copy paste from the Python code seen here, which is the Python code. Let's go through it in more detail. Not much though, but the main HMAC authentication token that we are going to create is this one. This K signing uses the K service, which uses a K region, which uses a K date. K date is the date timestamp, which I generate like this because Godot doesn't have the STF. Because Godot doesn't have this function over here that Python has to convert easily date to a string. So I needed to do this in a more manual form. I think there are other codes in the internet to do that, but this is fine, this works. Other than that, I needed to create some header files or some header strings. I also need to hash the payload. My payload is basically the request parameters in a SHA-256 form. My request parameters is exactly this JSON that I send it to it. My authorization header goes through just getting a bunch of information. And finally, my header is the pool string array that HTTP request uses over here. Notice that the authorization header uses this signature, which is a hex digest. And the signing key, which goes into the signature, is that other digest over there, which I created here. So with all this out of the way, we managed to actually do the request to DynamoDB and get a proper response, as we saw near the beginning of the video. So other than some smaller changes that I did from my tutorials to show the little UI to ask for a name, this UI over here, I also added the DynamoDB scene as a singleton. And because of that, my global script has the access key and secret key. When it's ready, it connects to the DynamoDB and does a scan to get everything and loads everything into a local leaderboard for me. And every time that I have a new score, it also connects to the DynamoDB on style put item to include something new. I need to give the table name and the item that I want actually to change. If you go back, you'll notice that I have a game, which I have to specify the game is of type string. So this is how you specify that it's a string to be sent to DynamoDB. Here's also a string, which is my name, and a number, which I still need to send it as a string, but I set it as a number. And in the future, if you guys want me to do some more in-depth tutorial of how to use DynamoDB, let me know in the comments below and I will be happy to make a more in-depth tutorial for DynamoDB. If you want to also study a little bit more on how to use DynamoDB things, come to the documentation of Amazon in this website, which I'll also link in the description below, which has all the information you'll need for any kind of API request. For example, here is the scan one that we did. So nearly everything here is being set up with that code that I showed you. Scan is one of the ones that we use to actually retrieve the entire leaderboard. Scan is the one that we use to retrieve from DynamoDB the entire leaderboard to be able to show the user. And all we actually need to send is just this. The other one that we use is a but item, which is over here. If you click, you can also see a sample request in which it's very similar to what we just did. This is the request JSON. This one is the XAMZ target, and everything else is loaded for you basically. Remember, if you actually use a different region, not US East 1, remember to also specify it in the call to the DynamoDB node. So thank you for watching this somewhat short tutorial of how to use DynamoDB with Godot directly with no middleman and no server in the middle. I hope you liked it. I hope you can use the code in the GitHub below. Let me know also in the comments if you want me to create actually a proper add-on to Godot with this thing that I just created. But otherwise, have a great day. See you next time.